Alright, good afternoon. How you guys doing? Welcome back to Button a Day. My name's Dan Rutter. I'm a CAD modeler. I've been working in the film industry for the last 5 years, CADing up all kinds of hand props, set deck pieces, things like that. It's a brilliant job. Absolutely love it. It's an industry worth getting into if you can. Very exciting, and just it's a different job every day. I'm a massive geek, as I think a few of you might realise by now. One of those things I like is Dungeons and Dragons. I like playing it. Got a campaign running with some friends of mine, and I like listening to people. And I'm a big fan of Critical Role, D&D podcast done over in the States by a group of incredibly talented voice actors, and it's amazing. And one of the things they talk about in their current campaign is this thing here, which is a Luxon beacon, which Matt, the DM, Matt Mercer, describes as this kind of pulsing grey crystal with an elaborate metalwork frame to it, and it sort of grants the users of it, the people who stop and stare into it, and they kind of get taken in, and they can see versions of themselves and different timelines, and yeah, it just sounds really cool. And it's one of those things I thought I'd love one of those up on my shelf, but when am I ever going to have time to draw that up? And then, lockdown happens. So that's what I'm going to have a look at today. Now, I did do a little live broadcast on Friday, and it all went to pot. But, if you were lucky enough to saw that, this one's better. I've learned a lot about ratios of drawing a proper dodecahedron where all your edges are absolutely even. And the fantastic thing is you do it in about 3 features. So that's going to be quite exciting to look at. So let's just have a look at what we've got going on. This is sort of a Luxon beacon idea. And click on here. Let's just do that. So we've got this sort of framework bit here, which I would like to print separately to the stone. Maybe get it metal plated, painted up, and we've got these handles. Now Matt describes that there are a few different ones of these scattered around Wildmount. So although I'm being inspired by this design, I am going to put my own sort of personal touch on it. So these sort of joints here, I want to make a nice feature of those. And I'm pretty sure at one point he describes there being symbols and markings, like it's a highly detailed sort of framework to it, giving it a lot of, somebody spent a lot of time and effort, it's obviously mean to the world kind of thing. So I'm going to look at maybe doing that. We might model something up in SolidWorks and then put it into ZBrush in another video, and we'll start adding those textures and details. And another thing that's interested me is Matt's description of the pulsing light. And also, as you sort of stare into it, seeing these sort of trails of light, these different sort of paths of possibility. And I was inspired by these guys at Deep Light IO, who have made these sort of infinity dodecahedrons. Now, the internet is full of these. I love this idea of being able to look into it and see these sort of swirling light patterns. So I want to kind of incorporate that. Now this is achieved by having a 2-way mirror as the faces of your dodecahedron, and then inside you've got like a sort of a smart RGB LED strip, something like NeoPixel, where you can then run sort of patterns and different colors, and then that gets bounced around like some sort of crazy kaleidoscope. Now the only tweak I want to make to this is I still want it to look like it's a stone pattern on this sort of outside face here. And for that, I'm thinking I'm going to make a texture that I'm going to then mold and maybe pour clear cast acrylic into, like a clear cast resin, and then sit my laser cut 2-way mirror hexagons into that mold. So when they come out, they have that texture on the surface. I don't mind if you don't see a completely crisp, clean image when you see through it. I just want that effect of it looking like it's full of all these crazy trails of light. And that's something I've not seen anybody do yet, so I'm quite excited to look at how we're going to manage that. I've looked into the 2-way acrylic, the 2-way mirror, it is quite pricey. If you want to buy the acrylic that's already kind of laminated up like that, you can use like a window tint foil that you can then apply to the acrylic. I'm not sure what I'm going to do at the minute. I know that I can buy the acrylic in 3mm thickness, so I'm probably going to draw everything based on that. 3mm is a fairly substantial size without it being too heavy. And I think whether I go with putting a tint foil on it or whether or not I buy the actual acrylic, that sort of gives me some options. The other thing I've looked at are strips of LEDs. And I can get really densely packed ones like this from Adafruit and NeoPixel ones. They're about 10mm wide across here, so I have to kind of bear that in mind. Other things to take into account when drawing up a prop is, what if something goes wrong with the lights? You know, I need to be able to get into that so I can make sure I can fix it. So let's have some sort of door, or maybe split the whole thing in half, which might help with wiring it up. And obviously if I'm running smart RGBs, I'm going to need a power pack, I'm going to need a board, so power, and some sort of Arduino, something like that. Do I put that inside the sphere, which I think you'll then see lots? I think it needs to be external, is my kind of current thinking. Now if I've got some handles going on around here, am I able to make these handles big enough maybe that I can fit a board in them, or is that just going to look ridiculous? So I might look at doing, maybe there's a port, a little hole on the handle that you can plug a cable into, then run it up your sleeve to a power pack, or maybe there's another port on the bottom, so you can have a plinth if it is just sat on your shelf that has power and a board built in, and it just plugs into that. These are all things I kind of want to look at and we're going to explore as we go. But first things first, let's draw a dodecahedron that has nice flat even sides that we can sort of then model on and start to work out this frame. Matt helpfully describes this using hand gestures at something about this size. I've kind of gone for about the size of a bowling ball, which is 215mm diameter. So we're going to kind of go based on there. But I'm also going to draw this in a way that we can change the size of this dodecahedron by altering just one dimension. So it's going to be quite quick and easy for us to change the size and get something we like. So without further ado, as they say, let's get cracking. So I'm going to open well, here's one I prepared earlier. That's what we're going to aim for. I'm going to start a new drawing, and as you can see, I've done this just using a boss extrude, a mirror, a move, bodies, and a combine. You know, it's pretty simple stuff, but it took a lot of thinking and a lot of searching to find certain ratios and mathematical answers. So let's start a new part. We're going to start by doing a sketch on the top plane, and hopefully we've got this sort of polygon shape. As long as I remember to make this 5 sides, and I'm going to go for this having a circumscribed circle, so the circle outside of it. I'm just going to draw a basic shape there. Now at the minute my entire sketch is blue because it's as yet undefined. So to start fixing that up, I'm going to select this bottom line here. I'm just going to say that is horizontal, so I know that it can't twist. I want to set a size for this circle, but I also know that this is the dimension that I want to be able to change in order to scale up the entire thing. So I'm going to actually make, we'll exit that sketch, we're going to make a little sort of equation, a global variable, what's the word? So if I make a global variable here and call it face size, I'm going to give that a value of, let's say 115 millimeters as a diameter. And then there are some other little things we want to put in here, one of which is ratio. Now, this will make sense, and this is something I had to try and work out. So I want to work out the height between the bottom surface of a dodecahedron and the top. So what is that dimension there? And there is a ratio for that, which is a little mathematical equation, which is sine brackets 18 plus 1, which I could give you just the answer to that, or we can do it properly. So we'll do sine 18 close brackets plus 1. Select. So that comes out at 1.30902. Crazy numbers. How anybody managed to draw these up without the aid of computers or calculators, hats off to all those mad Greek guys. So then we want to know that the height we're going to extrude this to reach the top. We'll put a value in here called height. So okay, well that height is equal to global variable. So we're going to go, that is the face size times, put a star in there, the global variable, our ratio value. So the height we want to extrude is going to be that face size times that ratio. Select. Okay. So now we've got those, we can go back into this sketch. Our dimension tool, we're just going to dimension this outside circle here. And we're going to do an equals, and that brings up our global variables, and we say, okay, that is our face size. Okay. Now we can, so it's all gone black, so we've now specified everything. It knows where it is because it's fixed to the center of our origin point. We know the outside dimension of our face, and we know it's locked so that that bottom line is horizontal, it can't twist or rotate. You always want to get your sketches locked off and fully defined. Once we come out of that, we can do a feature here. We'll do a texture boss, an extrude boss base. Select our sketch. Now, for our height value in here, where it says 10 millimeters at the moment, we can do equals again. Call up our global variable and choose height. And that's now going to be the exact height of our dodecahedron based on each face being that size. The next thing to do here is I want to work out the angle between each face of a dodecahedron. Now, when you look online and you look at lots of places, it says it is 116.57 degrees, which, fair enough, that's all right, but it's not. When you actually read it, it says it's about 116.57 degrees. What it actually works out to be, I've got it written over here, is, well, slightly different. Okay, let's have a look. So we'll do our draft angle here. We're going to draft outwards, and actually it's the last thing I typed in here. The reason it's come up as 26.56505819 is because we are not going from this face to this face. We're going as 90 degrees up, so whatever was going to go in here is going to be minus 90. So if we try that, 116.57 minus 90, that comes in at 26.57 degrees. You kind of think, well, that should be all right. But like I say, it's actually not. It needs to be to as many decimal places as we can get it to, or else you end up with slight indiscrepancies. So the actual number is going to be 26.56505118. This is what was doing me in last time. Once we're happy with that, we can press OK, and we actually have half of our dodecahedron already drawn. Now we want to make a mirror copy of this. We want our mirror plane to be exactly in the middle of this shape. So if we create a new reference geometry, a new plane here, we can select our top face and our bottom face, and it just puts it nice and equally in the middle. The nice thing about doing that is if we change the height that face will still be selected, and therefore our middle plane will move in relationship to the height that we make it, so it will always be in the middle of that shape. Okay, so now we can do a mirror. Got our plane selected anyway as our mirror face, and the body we would like to copy is this one. We want to make sure it doesn't merge. At the minute we want to make them two separate bodies. So we'll untick merge, and that'll come in as its own separate body there. Okay, well, almost there, almost there. So the next thing to do is we want to rotate one of these shapes around by 36 degrees. And we're going to want a central pivot point to rotate that around. So we're going to make an axis. So again, under our reference geometry up here, we have our axis. And we're going to go two planes. Because we built everything based around that central origin point, we know that the planes we already have, our default planes, our front, back, top, already intersect that point. So if we choose our right plane and our front plane, okay, we get this little sort of axis point here. Make that a little bit bigger just so it pokes out through the top, so it's easier to select. And then we can call up our move copy bodies command. Now again, I keep going about it, this little search bar at the top is absolutely fantastic if you're trying to find stuff. If you want to know where it is in your menus, you can just sort of select this little eyeball, and it sort of takes over your mouse and clicks and shows you where it all is. So it's underneath your insert surfaces, move copy body. Select that. Now the body we would like to change is going to be this bottom one. It doesn't have to be, it can be either of them, but I'm going to go for this bottom one here. And here we can choose our the bit we want to rotate around. So this is where our axis comes in. Because weirdly, if I look down from above, you see the center point that it wants to rotate around by default isn't actually central to our hexagon that we've drawn. It's also not on the origin, and I think it's to do with the fact that we've got a point, so the distance between here and our origin point is further than here to our flat point. So it is central to the shape, but at the same time not, if that makes any weird sense. So our rotation reference we can select here, we choose that axis, and the reason we come up with 36 degrees is if we do 360 divided by 5, because there are 5 shapes, 5 sides, it rotates, but you can't really see anything. You get 72. So you can either do 72 divided by half, or you can just do, instead of dividing it by 5, divided by 10. So 360 divided by 10, nice and simple, 36. There we go. So you can see that our point is now central. Choose OK. Good news, we're almost there. One more thing to do. So we now have our two intersecting shapes. We want to do a combine feature. So type in combine. And instead of adding them together or subtracting them apart, we want to do the common area. So the common area, we select both of these bodies here and here. And then OK. There we go, we have our dodecahedron. If we click on one of these edges, you can see here it's saying our edge length is 67.593, blah blah blah. And if we click on any of the other edges, you know, we're out by thousandths of a millimeter, so that's absolutely fine for what we want. Once we're there, we want to check the size of this thing. So I was saying a bowling ball is 215 mil in diameter. So we're going to start a sketch just on this mid plane here. Just sketch on that. Draw out a circle. I'm going to say that is 215 as a diameter. What we'll even do for fun, we'll make it 3D so we can see what's going on. So we can just do a little center thing, and we're just going to trim one side of this off. Feature, revolve boss base, and for the revolve we just need to specify an axis of rotation, which is going to be this line here, so it sort of like fans around it. Okay, and we don't want to merge it at the moment. Okay, so we have a ball. Now if we right click on this, we can change the transparency and sort of ghost it, so we can still see our shape inside. And now you see it's just maybe a little bit too small, so if we want to change that size, it's now really nice and easy because we've done it all through to these global variables. If we come into our equations and I'll drop down here, we've got our face size. We can manage equations and just change that value. So maybe we up it to 125. Okay. It rebuilds everything. So we're a little bit closer to the edge, not quite there yet. Let's do another one. Let's change it to 135. Now we're just poking through those edges. I think that's a pretty good size. Check these edge sizes. That's sort of like 79.4, 9.3 mil per edge. It's pretty good. I don't want to make it too big, so I've got to buy more acrylic. It's going to be too big and too cumbersome. I think based on Matt's description of it being about the size of a bowling ball, obviously we've got the handles going on top of it as well, but I think that's a pretty good start. I'm happy with that anyway. So once we're good with that, we can just hide our bowling ball image and we can start looking at how we're going to make that kind of framework. So we're going to do a little sketch just on this top face here. Now again, I'm going to have to do a sketch on the top face and the bottom face, and then on two of these faces, one on the top, one on the bottom. These ones I can then rotate round. If I want all the faces to be the same, I could create some more global variables. So I'm just calling those dimensions in. So if I do want to change the width or the angle of my framework, I can do that much simpler. So I'm going to do that actually, which is something I have not done on any previous sort of mock-up of this. So let's have a go. So we go Tools, Equations, and we're going to call this frame width. Give that a value of 5 millimeters. And we're going to call in a frame angle. And we're going to make that to 30. Do one more, and we're going to call that frame fillet. Going to make that 20. Okay, so we've got some global variables in there that we can now call upon. So let's start a sketch on our top face. Do an offset. We'll offset this face here. We will reverse that, and this is where we just do a little equals. Oh, interesting. Doesn't let you do a global variable as an offset entity. That 5. Oh, so I've still got equals there. 5. Okay. So I'm going to delete that. We'll try doing this a different way. I really want to use those global variables because it's going to save us so much time. So instead, let's convert that entity so we get this as some geometry here. And now let's just draw a new pentagon. So we'll just draw one out here. Put in some options. We can say this line here and this line here are parallel. We're just going to specify a distance now between this line and this line. That we want equals her, and now we can say that is our frame width, 5 mil. Okay. Come out of our sketch, do a feature extruded cut, because we've got two concentric full shapes. It thinks we want to do the area between them. So you can just change the select contours, clear that, just select our inside shape. Our depth. Probably make that, say, 5mm. Draft angle. Let's see if I can do that as an equal. Yeah, global variable. We can call that our frame angle. Okay. So that gives us this. And then we can do a fillet. So let's select one edge. I can choose this option here, connected end loops. Does that. And again, here we've got global variable, and we will call that our frame fillet, which we've set to 20. Okay. Right. So far that makes sense. Let's do the bottom one quickly. So we do the same thing. Do a little sketch. Sketch on the bottom. Convert our entities. We didn't do an offset in the end. We redrew our shape. Put our center point there. Choose any of these two edges, say that they are parallel, and then we'll just define our distance between them. That we set as our global variable, which is our frame width. Okay. Features, extruded cut. Deselect our sketch. Choose our middle. We set that to 5 last time. I could have set a depth as a global variable, and I might do that later. I might point back through our tree, add a global variable, and then reapply it, but at the minute we'll stick with that. And this angle here, put in as our global variable. This is for the draft angle, which is our frame angle here of 30. Okay, and then last thing is our fillets. Select an edge. Okay. And you know, it's come up as 20, and you might look at it and go, oh, that's brilliant, and then okay, but then you're not linking it to that global variable, so it won't change when you update. You always need to make sure you do that equals global variable and frame fillet, or whatever variable you want to apply to it. Okay, so that's our top and bottom. Like I say, now we only have these two left to do. So, quick sketch on this face here. Now this is awkward, I don't have that origin point to get the exact center of this face. So I'm going to make a perimeter circle. I can select an edge, another edge, and a third edge. As long as that circle is tangent to those 3 edges, I know that point there is my center. I'm happy with that. Actually apply those so they lock in. So select both these parts and choose tangent. Now we get this little green icon showing that that sort of relationship has been applied. This one here, and finally this one down here. Two things selected. Shift and tangent. So now that's gone black, it's locked in, it's not going to move anywhere. The other thing I can do here is I can just right click and say I want to make a construction geometry, because I don't need that geometry for my cut extrude, it's probably just going to get in the way. So I can make it construction, it's just there for my sort of benefit. So now I've got that center point to snap to, draw out our shape. I can choose any 2 of these edges so they are parallel. And we'll just specify a distance between them. Equals global variables, frame, or width. Okay. Do our extruded cut. And call in our global variable for that draft angle. Frame angle, there we go. Shouldn't whistle down the microphone, I do apologise. Okay, so fillets. These quick selection tools are brilliant. So this one tries to map around the shape and find the edges, and it highlights them pink, which is quite cool. See what's going on. This one is any connected faces, so you see it's actually selecting more edges. I can zoom out and do that. select another edge first. And it starts ringing these up, and I can do any of the edges that are to do with that face. Yeah, it's kind of crazy, but makes life much easier here. Again, change this to a global variable so we can update it. It's going to be our frame fillet. Okay, one more to do. Let's do a quick sketch on this face. We did the same little trick with our circle. Snap that to that. Do the same thing where we can actually apply those relationships. Last thing, this bottom one here. It could be any three edges really, doesn't matter. Locked in, that construction plane. From that center point, draw our shape up. Any two edges, tell them they're parallel, and define the distance. Distance is going to be a global variable, and it is the frame width. Okay, features, extruded cut. Set this angle again to our global variable, frame angle, and then OK. Final thing's the fillet. Select one, smart select the others, set that to be a global variable. Fillet. Okay. So now we know that we already have an axis in place. We can actually rotate these round to do the other faces, which saves a fair amount of work. So we're going to do a circular pattern and choose our axis point. Then for the features that we're going to do, just going to clear that one, you've got to kind of do them in the right order. If you try and do a fillet and then a cut, and the fillet is relying on information from the cut, it won't work. So we have to do things in the right order. So we can choose any face, so we choose one of these edges, we choose its bump face, anything that is created by the feature. If I select that, it's going to say, okay, there's that cut. Select this one, there's that cut. Then I can choose any of these fillets, and it's going to add those. Now it's important to say you want it to do it as a full 360 rotation 5 times. Sometimes this is still set on previous number and it gives you a preview, and that's not going to work. So we set that to 5, same number of faces as we've got running around it, and we can confirm that. Okay, so that's kind of looking pretty cool, I think. That's getting there. Other little useful things we can do, if we go back through our timeline, and this might break some stuff, but I'm all happy with that, you know, we don't panic. And I'm going to shell this because I want it to be hollow. So if I choose the shell feature, I know that I've just cut everything down to a depth of 5 mil. So if I give it a wall thickness of 5 mil, choose this body, do a little preview, so our inside shape. So that's because I selected a face, so edit that. And instead of selecting the face, we want to select the whole body. So we do that. Now it doesn't look any different, but if I do a little section slice through it, you can see we've actually hollowed it out. So now if I do my cut extrude and my fillet on that top, we have an opening. Run that right the way down to all our holes. Now the reason I'm saying I don't know if this is going to necessarily work is because I selected the faces that were made from this when I was choosing the cut feature. So but hey, you know, SolidWorks is smart enough to go, okay, that face isn't there, but I know the feature that you wanted to rotate, so it's fine. So that gives us our sort of framework going on. So why do we do global variables? Well, what if, you know, I'm looking at this thinking maybe this is a bit chunky or a bit skinny. Why don't we change that frame width? So we do our manage equations up here. We have our frame width here, which is 5. Now what if we set that to 8? Choose OK. It's going to update all of these, and we can get sort of instant feedback on how we think that looks. Now, I think I preferred it when it was skinnier. So instead, I'm actually going to make it 4, and make it even a little bit skinnier still. I want it to look quite sort of delicate. And the other thing I'm going to change is this angle. Instead of 30, let's go like way more severe with it. Let's go 60. See how that looks. Okay. Kind of liking that. Now, if I'm looking at 3D printing this cage at the minute, if I do a little section cut through there, you see that all of these come down to this sort of wafer thin edge. Now I'll have support material on there, it's bound to chip, it's going to break, it's going to be a bit of a nightmare, and it's a bit of a no-no in general if you're producing things that have a wafer thin edge like this. Any machining process is going to have real trouble. So I'm going to add a small sort of radius detail around that. So we'll do a little fillet, something quite small, maybe 1/2 mil. I can just go around and select all of these edges on here. Now hopefully I know that there are 12 edges. So on here, I've got 5 of them. 6, 7, 8, 9, 10, 11, and finally that one there. Select that. So now if I do that section cut through it again, you don't have that same kind of wafer thin issue that we were going to have. We've got something with a bit of substance that can actually support itself. So that's all cool. Other things I might do, I might add a fillet to the outside edge so we don't get this sort of sharp angle. It's more, like I say, quite organic. So we can do a fillet on here. Up that to 4 mil, bigger 6 mil. Select all of these edges. There's nice sort of detail on the knuckles where they join up. Just go down and select all of these. And again, I could set these up as a global variable, but they're all going to be in the one feature. So it's easy enough for me to go in and change it. Whereas it was, because we were patterning around and we had to do multiple sketches of multiple faces, we would have to go in and edit at least 4 different sketches to change the width of our framework. So it's much easier to use a global variable in that instance. I might look at doing a video on using global variables and functions in Fusion 360 at a later date, if that's something anybody would find useful. Recently just got my certified professional expert in SolidWorks. Yeah, I know it's geeky and a bit of a mouthful, but it gave me something to do over lockdown, so I kind of feel I should be using SolidWorks a bit more, at least for a while. I mean, I use it every day at work. It's my go-to program. So we have 30 edges, that's right, for a dodecahedron. So they're all selected. Okay, so we have something like that. We can drop a bit of colour on this, so we get some idea of how things are going to start looking. I'm imagining it's going to be a sort of nice gold. Yeah, let's go super shiny. I'm not going to do it super shiny. Something like that. And if I turn off these edges and add a little bit of perspective and some ambient occlusion and some shadows, get something like this on the go. So I think we're kind of getting there with it, which is cool. So we need to work out now where we're going to split this up so that it can be assembled. I've got to look at how I'm going to position my hexagons on the inside of here, and also how I'm going to put a little support detail to stick the LEDs to. And actually this was a good thing to check is what the distance is between this edge and this edge. See whether we're going to fit some LEDs in there or whether I need to find something skinnier. Okay, so the minimum distance is 13 mil and the LEDs I've looked at are 10 mil wide, so potentially that should be absolutely fine. Yeah, no, that should be cool. So I'm thinking I'm going to have a little rectangular, not rectangular, a pentagon shape. Just do a little quick sketch on here. That shape. Do a quick offset. I always want to do an offset on these things. I don't want it to be super tight. That's just no help to anybody. Might do 3 mil. Okay. Extrude. Just extrude that out. Pretend that's our 3 mil piece of acrylic in there. Just like that. Make sure we go in the correct direction. 3 mil. The other thing I'm going to do, rather than starting that extrude directly from the face that I drew it on, I'm just going to do a tiny offset, like 0.2 of a mil, something that allows for glue. It's something I've got into the habit of doing, so there's just that little bit of tolerance in everything. It allows for paint. And if I'm going to get this printed and then plated, I actually need to up that to maybe 0.4 or even half a mil to allow for the layers of metal that are grown over the top of it. But for the minute we'll do 0.2 and then we'll see how we go from there. I'm going to untick merge result. It shouldn't merge anyway, it's not touching anything, but good habit. So that's going to be our clear hexagons. Now that's 3 mil without the layer of clear resin on top of it. Now I'm not sure how much space I can get away with to allow for that. I want it to be fairly thin. I'm just going to have to allow a bit of leeway, maybe 1 or 2 mil should be enough. I shall chat to some of my pals who work in the casting process at work. The other thing I do, if I'm going to laser cut these hexagons out, it's a little thing, I'm just going to put a little rad on these edges. Just because really, corners are where things always get kind of bunched up, so I should make that quite big. My cat is desperately trying to chase a bird in the back garden. Now, I'm not sure he realizes that he is completely pure white and it's brilliant sunshine out there, and therefore he is radiating light right now. It's the most obvious thing, but bless him, you know, he's trying. Okay, well, I think we might stop it there for today. I'm going to go do some research, find some LEDs, and have a little think about how we might do this support, and we'll draw that up tomorrow. But yeah, thanks for watching, and if you've got any critiques, any questions, the other thing I want to do tomorrow we'll look at is these knuckles, this detail here. If we look back on this image, not that one, this one, we've got this sort of knuckle detail going on. So I want to elaborate that a little bit, and then obviously handles. So I'll work out what it is I want to draw, so you don't have to sit there watching me going, maybe this, maybe that. I'll go away and think about it, and we'll deal with that with tomorrow's video. Have a great day, guys. Stay safe, look after each other, and yeah, take care. Bye.